Hello everyone and welcome to the OS MasterMap Highways Paths webinar. I'm Diana Moraro and together with my colleague Philip Gang, as Hannah said, we will go through a technical deep dive explanation of the Highways Paths product. Let's first start with an overview of the product. So on the top of the screen you can see the three products in the family. Roads, routing and asset management, for which we had webinars last week, and as Hannah said, you can find links to them on the website. And then today's subject is the paths product. Below here you can see the features, the feature components listed with the orange boxes. So we will be talking about them today, path link, path node, ferry link, and so on. And you can also, we will also be discussing the relationships between the features and how they relate to the other two products as well. Also, please note that during this webinar, we will be making references to our technical product specification document, and this can be found attached to the webinar window on the right. So you have the handouts section, you can find it there, or if you need it at a later date, this can also be found on the OS Highways support website page. Let's start with the next diagram of the path network. You can see now on the slide, as I said, the different feature components and the relationships to one another. Also, I would mention the path network is a topologically structured link and node network, which is made up of the following feature types you can see on the screen: path link, path node, and then also you have the road features elements. You have the road link. It relates back to the road network through the road link. You also have the ferry network represented here, ferry terminal, ferry node, and the ferry link. Also, two essential features here are connecting link and connecting node. And then on the top of the list, you have basically the asset management and geo-authoritative information, also the highway dedication information that relates back to the street, or also back to the path link. Highway dedication, for example, relates back to the path link and back to the street. However, the maintenance, reinstatement, and special designation, they only relate back to the street information. Up next, I would like to also emphasize the essential role of the connecting link and connecting roads. So as you can see now on the screen, you have basically the path network and the road network. So with green, you can see the path network, and you have the road network with red. At the moment, you cannot see the connection between the two. However, if I click up next, you can see now loading the connecting link and connecting nodes. So these are used basically to connect the road and the path network. You can see the connecting link has been snapped to the road link here. Again, they're used for connectivity purposes, so they are logical connections. They do not represent a feature in the real world. However, they are connecting the two networks together and making a better product to run queries and analysis in the paths product. Also, I would mention connecting links, for example, have geometry, which they didn't have in the ITN in the past. Also, as an introduction to our paths product, I would like to discuss with you the common attributes we have across all the highways portfolio, so across all the products in highways. They are inherited, many of them have been inherited from the Inspire transport network model. You can see now on the left side, you have the GML ID, which is the first identifier I would like to discuss about. This is a very important identifier as it's basically the one that will help you relate features to each other. And if it comes from OS, you will have a TOID reference as well, an OSGB followed by 16-digit format. If it comes from an NSG, basically network, you will have USRN followed by the 8-digit numbers. And then this, again, this is the essential one which helps you relate features. You also have an additional identifier, which is actually the identifier attribute. This comprises of a code base and will also have the URL representing the ID. However, in this case, as you can see now, it just has a number. It doesn't have the prefix. It doesn't have OSGB or USRN. And then the final identifier, the third one, is the Inspire ID, which comprises of a local ID, and then you also have the number without the prefix, so without the OSGB and USRN in the front. But we'll also have the namespace, which will be Ordnance Survey. So these are the identifiers. Then you also have some lifecycle information in here. The primary one I would like to begin with is a begin lifespan version. And that is an attribute which will tell you that whenever a new version of the feature exists in the product, this date will be updated with the publication date of that feature. Again, this is used only in change-only update, which would be a feature in a future release. You also then get some additional lifecycle information, which is valid from and valid to. These attributes are talking about the feature in relative terms of the actual real world. So this is not when the data changed, but when from when that feature started to exist in the real world. You can find this example, for example, in the street feature, where you will have information when that street is valid from. So that is when the street was actually built. We are only populating this for the street at the moment. However, there are also other common attributes I would like to refer to besides the life cycle, and that is reason for change. The reason for change attribute is used across all features found within the OS MasterMap highways network. The code list for the reason for change can be found at page 49 in the paths technical specification document. Reason for change has the code list, and the constituents of the code list are new if the new feature has been added, modified geometry if the geometry of the feature has been altered, modified attributes if the attributes have been changed, or you can have modified geometry and attributes if both have been changed, or end of life. This value is only used for change-only update orders. And with that, I would like to close now the common attributes for the paths product, and we will start now on the feature-by-feature level, explaining the attribution and the structure of each feature. So I would like to hand it now over to Phil, my colleague, to start with the path links. So over to you, Phil.
Thank you, Diana. Yes, hello everybody. The first feature we're going to look at, or rather the first couple of features, are going to be the path link and the path node. And although we're handling them separately, it's important to understand they work together to provide the base geometry of the network. In terms of the path link, a path link is a connection between nodes, and you can just hopefully see it on the screen here. So this highlighted sort of turquoise link. So that'll be the path link, and we have a node on each side, and the nodes would be referenced in the path link as start node and end node. We capture path links where a route cannot be determined from the roads network, where a route follows a canal or a towpath, and where there are paths over footbridges or under subways. However, we explicitly do not capture path links where they run parallel to a road network. So for example, they're the pavement, hence why in the image you can't see a path link running along here parallel to the road. We don't capture them where they are connected to a motorway, and we don't capture them where there is a physical obstruction preventing connection. Path links will be split for connectivity purposes. So for example, at junctions, as we can see here underneath the marker, and we can see it up here as well. And there the routes actually connect. You can move between the routes, or between the paths rather. However, we also split them where a grade separation occurs. And the grade separation is best explained by the image on the right. And if you ignore the cars for the time being and just imagine the two of them being footpaths, here we can clearly see that the two paths, although they cross, they don't, you can't move between them at this point. And this is what we call a grade separation. So they run at two different levels physically. And this is referenced in the path link by a start grade separation and end grade separation attribute. And best way to look at it is if you have a single point where the four links in this case come together, two of them would share one grade separation value and the other two would share another. In terms of how we gather the data for the path links, we match the National Street Gazetteer data geospatially against OS path geometry. And the geometry that we provide is a three-dimensional 3D line, which represents the alignment of the path link. Now, with that come a whole bunch of attributes, and I'll start with the mandatory ones first. We have a fictitious attribute, and fictitious doesn't mean that we've made up the link or that the link doesn't exist or that we were trying to fool you. The fictitious attribute is intended to show you, we know there is a link between the two nodes that we put a link against, but we don't actually know the exact geometry. So it's usually a straight line between the nodes as opposed to an actual surveyed geometry. Various reasons for this, for example, heavy tree cover could be one reason. We, as I already said, provide the start grade separation and end grade separation value. We also provide a form of way value, and the form of way explains what form the path link takes on the ground. So, for example, is it a path or is it a footbridge? We provide a provenance value. The provenance gives the capture accuracy of the height value within the link. So not the actual geospatial accuracy, it's the actual height accuracy overall. And this can be multiple sources. You can find more information on that in the technical specification. Very broadly boils down to, is it urban capture specification or mountain moorland capture specification, or rural for that matter. We provide a match status, and the match status attribute shows whether the path link has been matched against a feature in the National Street Gazetteer. And we provide a length attribute, which provides the length of the path link in meters. So these are the mandatory attributes. You will find those with every single path link. However, there are also a few optional attributes which are worth noting. The first one being the path name. And the path name is a so-called localized name string. A localized name string is one where there are multiple languages. We will provide the 3-letter ISO code for the language. So for example, if you have a path name in Welsh, you will have the Welsh 3-letter ISO code, or if it's an English one, you will have the English one. And the path name is populated with the name from the street, where the street type is one of designated street name. Otherwise, it's populated from the path. This will become clearer when we're looking at the actual street as a feature, because it's explained more in that, but that's where the path link name comes from as well. We also provide the alternate name, and this again is a localized name string, and it's populated if the path name that we have found, and that's populated from the street, is different to the one that we hold at OS. So we provide you with both pieces of information, with both names if there are multiple ones. We provide a surface type attribute. This is the OS MasterMap topo surface type attribute. We also provide a cycle facility. However, word of caution with the cycle facility, at the moment, we only provide the value of unknown type of cycle route along footway, and this is not populated fully. However, if it were to be populated more broadly, then it would identify whether a path link has facilities for cyclists. We provide an alternate identifier, and this is a collection of the identifiers of the matched elementary street units from the National Street Gazetteer or the Trunk Road Street Gazetteer. So naturally, if match status is matched, then the alternate identifier should be populated. We also provide the elevation gain, and the elevation gain will give the elevation along the path link in meters in both directions, and it is provided in direction and against direction, and the direction is determined by the digitizing direction of the path link. You can find out the digitizing direction by looking at how the coordinates are ordered. We also provide associations, and here the two main ones are the start node and the end node. So these will be the nodes that the path link connects to. And we also provide a forms part of, which identifies any path or street that the path link forms part of, and a related area, which provides the OS MasterMap topo GML ID of the relevant topographic area that's covering the path. So that's the path link. Now we'll go on to the path node. And as I said, they work together, they belong together in that sense, so it's best to cover them off in one go. And the path node very simply provides the connecting breaks within the network. And the network splits where an attribute changes, an intersection or crossing of path links occurs, regardless of whether they actually physically connect or whether it's a grade separation, as already mentioned, and where a path link starts and ends. The geometry is a standard point geometry, and the only mandatory attribute we have here is the form of road node value. And the form of road node value is a description of the node function within the network. And this can be either one of junction, where multiple path links cross, a pseudo node, where only two links connect, and a road end, where only one link connects. We also provide an optional attribute of classification, and you can see one here. And classification will be populated with grade separation, where the node provides a grade separation. So that's your indication that that node will have links with different start and end grade separations on them. That's a whirlwind tour of the path link and the node, and I will hand you back to Dana now to explain exactly how we can actually link the two together. And you can find all the diagrams we're showing you, by the way, in the technical specification, which you also find attached on the right-hand book on your webinar panel somewhere. Okay, over to you, Dana.
Thank you, Phil. Up next, we have a connecting link and connecting node. As Phil said, this information can also be found in the technical spec document. For connecting link, you can find it at page 24, and for the connecting node, page 25 in the paths technical document. In terms of the connecting link and connecting node, they have been introduced basically again to enable a connection between the road network and the path network without actually splitting the road network. Connecting link feature is a linear spatial object which basically represents a logical connection between the path network and the road network, and they do not represent an actual feature in the real world unless it's topologically structured like that. A connecting link will always reference a path node and a connecting node. On the other hand, the connecting node, which is basically a point feature that identifies the point along the road link, you can see in the example as well, and provides a reference to the road link. It has snap to the road link. Again, is not actually split at the location of the connecting node, and the connecting node is referenced as well by connecting link. Again, the three-dimensional geometry here has been applied to connecting link and connecting node feature. This has been done to actually facilitate routing that requires coincidence of coordinates. Given the nature of the connecting feature, this geometry is again only for connectivity purposes only. Now, to explain a bit more on the attribution side of things, you can see now the diagram on the screen for both connecting node and connecting link. Also shows how the connecting node basically relates back to the road link, whereas the connecting link relates back to the path node. In terms of attribution, besides the common attribution mentioned in the beginning, for connecting link, we have the geometry attribute. Again, this is an implied connection between the road link and the path link. And this is, note that this is represented as a three-dimensional geometry to facilitate connectivity, but it's only a logical connection and not actually a physical alignment. Another attribute of the connecting link is the connecting node information. The connecting node attribute is basically a reference to the connecting node, which the connecting link references to. And then you also have an attribute called path node. This is a reference to the path node, which the connecting link references to. Also, for the connecting node feature, We have, again, the geometry attribute, which is the location of the node, which indicates where the path network connects to the road network. We also have the road link attribute in the connecting node. The road link attribute is an actual, is basically a voidable attribute. However, again, it's a reference to the road link which the connecting node has been snapped to. With that in mind, we basically covered the connecting link and connecting node attributes. Again, in the blue box here, you can see the change value called this, and this is actually from the common attribute called reason for change, which is populate and change only orders. That summarizes all the attributes here. Up next, we have the path feature, which I would like to hand it back over to Phil to explain a bit more on it. So over to you, Phil.
Yes, thank you. So having a look at the path feature, there are two features that collect path links into a more manageable feature or more usable feature. One is the path, the other one is the street. There is a key difference in that the street has far more attribution with it, and also where the data comes from. Looking at the path first, we provided as a named collection of named path link features. It is provided by named paths within the OS paths data, so our own data. And the key thing with paths is they continue across authority boundaries. So where streets split at authority boundaries, paths continue across them, they do not split. Path links can be referenced by multiple paths, so there could be multiple paths containing the same path links. And in terms of the attribution, it's a very simple feature. We have two mandatory attributions. The first one being the path name, and this is a localized name string, as explained earlier. And where more than one name is given, then the language identifier is provided, and it's simply the name of the path as held by Ordnance Survey. The second one is a link attribution, and actually it's an aggregation more than an attribution. So this is a list referencing all the path link features that make up this path feature. And to make this a bit clearer, I'll just go back to the example we just had. Here you can see the path name and also the link attribute, which gives you all of the path links connected. And you've got one link here, another one here, and another one here. So you've got three path links which are all referenced. Going onto the street feature, as you can see by the size of the writing in the blue box, there's a lot more detail on this. The street feature will only reference streets made up of path links within the path network. So you won't find streets that are made up of road links. And the data is provided by the National Street Gazetteer, so this is where the match data comes in. A street exists where an elementary street unit in the National Street Gazetteer has been matched. It represents a complete street or the section of a street falling within the single administrative unit, town or locality. And if you look at the picture, you might be able to see that yellow-orange dashed line going across. That's to indicate an authority boundary, just a fictional one in this case. And as you can see, where previously the path was continuous, the street is here made up of just those two links. Potentially there is another street running down here in line with the path. A path link, again, can be referenced by multiple streets, and naturally that means a single path link can be referenced by multiple streets and paths, so there's no restriction on that. The street feature extends the road feature and adheres to the British Standard 7666, for those of you who know what that means. And the streets model in the paths network is identical to the streets model in the roads product. And what this means from a data management point of view is that you can store both street data in the same database without having conflicts or having to design the database differently. So it just makes managing the data a little bit easier, especially if you're interested in the street data. The geometry for the street is aggregated from the matched links that make up the street, and I will be explaining more about the names within the product in a second. However, there's also a names webinar available on the website, so have a look at that if you need more explanation of the names after this. In terms of the attribution, you can see from the diagram, it's quite a hefty diagram, and you can find this again in our technical specification as well. The mandatory attributes for this are the geometry provenance, and this is the source and accuracy of the height element of the geometry. So as I said earlier, this roughly boils down to urban versus rural versus mountain and moorland, and refers to the height value only. We provide a responsible authority attribute, and this is the authority responsible for the naming and numbering of this highway. We provide a street type, and this is the type of street as classified in the National Street Gazetteer. And this is where it becomes quite important in terms of naming, because depending on what classification you have there, the name will be different, or the naming that's expected will be different. We provide a link again, which is the aggregation of all path link features that make up the street feature. And we then also provide a whole bunch of optional features. In terms of the optional features, we provide a road classification feature. However, and this goes in line with this whole sharing of database thing. In paths, this will never be populated. So although we provide it, and I mention it specifically here, it's not populated in paths, it will be populated in roads though. So it's purely here because of that sharing of the database. We provide a descriptor, which is used to identify a street where no street name exists. However, we only provide a descriptor if the street type is one of officially described streets. So this is where the two interact a little. We provide a designated name, and this is an official name given by the designated street naming authority, but we only provide this if the street type is one of designated street name. So hopefully fairly self-explanatory if you're following this in the technical specification. We provide a local name, which is an unofficial local name associated with a highway, but this is only supplied if the street type is one of unofficial street name. And finally, if there was a numbered, which would be the road classification, it would only be there for the numbered street. But of course, this doesn't apply to paths, but it will apply to roads. We provide an administrative area, and this is the name of the administrative area the street is located within, and this is provided as a localized string. We may also provide a locality, and the locality is the populated place representing the locality that the street is located within. And we may also provide a town attribute, which is the settlement the street is within. However, this is not populated if locality is populated. So although we provide these three references to where it might be, at most two should be populated at any given time, if any. We also provide an operational state, and the operational state indicates whether this path is open, closed, under construction, for addressing only, etc. So there are multiple values. Again, you can find those in the technical specification. And finally, for the street feature, we provide an association that is the GSS code. And this is a reference to the ONS, Office of National Statistics, unique identifier of the administrative areas that adhere to this. And roles used to describe the authority in this case would be the upper tier local authority, lower tier local authority, or unitary local authority. And you will then also get the actual name of the authority in that as well. That concludes the path and street feature. The street is quite possibly the most sort of detailed part of this entire network, but we do provide some more information and also some non-land-based information, which Diana is going to look at with the ferry links and information.
Thank you, Phil. Excellent. So up next we have the ferry network. As Phil said, we will start with a ferry link example. You can see now loaded on the slide as well. A ferry link basically is a linear spatial object which represents the connectivity of a vehicular ferry route across a body of water. The ferry link will only be captured where the route is limited to pedestrian only in this case, and both terminals are within Great Britain, and there is a timetable service which is open to the public. You can see some of the attribution as well on the screen here, ID, vehicular ferry. We will go into detail in the diagram next. Another example of a feature, part of the ferry network, is the ferry node. The ferry node loaded now on the screen as well is a point spatial object which is used to represent the connectivity between the ferry links and where the ferry links will start and end. A ferry node feature may serve multiple ferry link features if more than one destination is served from the same location. Also, the ferry node will always be referenced by at least one ferry link as a consequence. Ferry terminal as well, and other feature in the ferry network. The ferry and the road network, the path network, elements are linked together to the ferry terminal. A ferry terminal is basically a logical connection between the two networks, and therefore there is no geometry supplied with those features. They will reference one path node and one ferry node. You can see as well in the attribution mentioned here, one of them is ferry node, one of them is path node, so you have the reference to the two. And again, they will, it's not on the screen here, but you also can have a reference to the OS MasterMap sites feature, so it links up to the other MasterMap product as well. Again, showing the relationship between the highways product and other MasterMap products. But to discuss a bit more on the ferry network attribution, you have now the diagram on the screen, which can also be found at page 35 in the paths technical spec document. And it shows again how the ferry link, ferry node, and ferry terminal have been connected together. They have attribution inherited from Inspire transport network, and also they form together basically the ferry network, which links back to the with the path network. To start off with the attribution for the ferry link, basically the ferry link will have as attribution, one of the first one I would like to mention is the center line geometry. This is the three-dimensional geometry that represents the connection between the ferry terminals. If we have a detailed alignment provided, it is only an indication of the route a vessel will take, and the third dimension is only provided for connectivity purposes and does not reflect any real-world value. I would like to mention also that we are looking at how we can maybe populate the geometry for the ferry links, and we are investigating to see how much we can improve the geometry and maybe actually provide topologically structured geometry for this. However, this is ongoing work, so please watch the space. Another attribute for the ferry link is fictitious, which is an indicator that the center line geometry I was mentioning earlier of the link is basically just a straight line with no intermediate control points. Again, unless the straight line actually represents the geography in the resolution of the data sets appropriately. So we have a few records that will be the actual geography, but we're looking in improving basically the records we have at the moment. We also have vehicular ferry attribute, which is an indicator if the ferry link represents a ferry that can be used by vehicles. However, for the paths product, this will always be set to false because we're looking only at pedestrian routes in this case. You also have the start node attribute, which will give you the node coincident with the first vertex of the geometry attribute, and then you have the end node association attribute. These are start node and end node are association type of attributes. The end node, as I said, will give you the node coincident with the last vertex of the geometry attribute. And with that, we will finalize the ferry link attribution. Moving on, we have the ferry node attribution. The ferry node attribution comprises of the geometry attribute, which basically gives you the location of the node, of the ferry node. You also have the form of waterway node attribution, which actually goes into more detail and gives you the description of the function of a waterway node in the water transport network. The form of waterway node has also a code list, which can be found at page 54 in the technical spec document, and it comprises of an attribute called the water terminal, and this basically gives you the location where the goods are transshipped across. So that is a ferry node attribution. For ferry terminal, finally, we have, again, for all of them, besides the common attribution, we have the type attribute I would like to emphasize. The type attribute of the ferry terminal gives you the categorization of the network connection, and it has a connection type value code list, which can be found at page 53 in the document, the paths document, and it has the intermodal value, which means that the connection between the two network elements in different transport networks that use a different transport mode. So basically, the connection represents a possibility for the transport of people or goods to change from one transport mode to another. So it gives you an indication you're moving from one type of transport network to another, terrestrial to water network. Also, you have on the ferry terminal, you have the reference to functional site attribute, and it gives you the reference to the site representation of the ferry network, of the ferry terminal, sorry, in the OS MasterMap site layer. So this is where you will find a reference to OS MasterMap sites product. And then you also have the element attribute for the ferry terminal. The element attribute in the ferry terminal is basically the one that allows you to reference back to the road node and the path node, or the ferry node. The type of node the element is referencing will be identified to a link type of attribute. Again, this is allowing you for network referencing, which we'll be discussing shortly. So with that in mind, this summarizes the ferry network attribution. Also, there are a few attributes which I didn't actually discuss much on the ferry terminal, and that is route operator, ferry terminal name, and ferry terminal code for the path ferries. At the moment, these are not, they're optional attributes, so they're not populated, but we are looking to see if this information can be captured or if we can source this type of data. They're more of a placeholder attributes which will be maybe populated in the future. So with that in mind, this is the ferry network and the paths product, and I will hand it back over to Phil now to discuss a bit more on the network referencing in the paths product. So over to you, Phil.
Thank you. So network referencing in the paths network is actually very straightforward. If you want to know more about network referencing in the highways product as a whole, I would urge you to watch the roads, routing and asset management information webinar, because we go into quite some depth in there. In terms of paths, we realistically use we use network referencing to relate informative features within the paths product to their geometries. So the following 4 features that we're going to be describing have no geometry of their own, but they do reference the network through this network reference. And with network references, we have 2 types. The first one is a straightforward network reference, and this references a whole street via its unique street identifier, so the USRN. And this applies to all of the 4 features: special designation, reinstatement, maintenance, and the highway dedication. And the example you can see on the screen at the moment, you can see you've got a very simple network reference. It tells you it's a network reference, and it gives you the element, which is, or element ID, which is a USRN, and you can then link straight to that. The slightly more complex network reference is a so-called network reference location. And this reference is part of a street feature. So where the previous one referenced the entire street feature, this one is only a section of that street feature. Again, it applies to special designations, reinstatement, maintenance, and highway dedication. And it can reference by 3 different mechanisms. The one you see here at the moment in the example is one by a location start and location endpoint. And with all of them, we provide a again, a element ID, which is the identifier to the street being referenced, so USRN. We provide a location description, which is a free text description, but we usually give a textual description from the NSG. And then in this case, with location start and location end, we provide the actual point of where the geometry starts and where it ends, or where the reference starts and where it ends. However, we can also provide, as you can see, possibly just about in the diagram, a location line or a location area. And the way to look at it, we're either going to be providing location start and end points, or a location line, or a location area. We're not going to be providing any more of those. And in terms of how a location line would work, this could be, for example, a section of a road that is known to have a cable underneath it, or various other bits and pieces. And it would simply provide the geometry of the line as a multi-curve. And you can see here the geometry down here, highlighted on your screen now. But also it still provides the element ID, and theoretically it should also provide the location description. We also, the final one would be the location area, and this would be a polygon encompassing something. So for example, it could be a neighborhood that has a certain special designation on it, or it could be an entire area of redevelopment that has specific requirements on road reinstatement. But generally speaking, it would be the same sort of principle as the line. So we have a multi-surface in this case. It is a polygon. It is a polygon made up of coordinates. So you get all the coordinates and you can basically see it that way. Again, however, we also reference the actual USRN this relates to. So this allows for slightly more efficient filtering in geospatial queries. In order to actually show how this fits together, I'll just start with the same with the first feature that we provide. The first one is maintenance, and maintenance provides information as to whether the maintenance of a highway or section of highway is a public expense or not. It does not provide an indication of ownership, and it uses the network reference and network reference location that I just explained there. In terms of the feature or the attributes we use, the mandatory attributes are highway authority, and this will be the responsible authority, or the authority the highway falls within, which is provided as a so-called responsible authority type feature. And this consists of the authority name and the authority identifier. We provide a maintenance responsibility, which is a maintenance value, and this will be maintainable at public expense, and you can see them in this green box, prospectively maintained at public expense, and basically the items listed here. You can get more information on those items in the code lists and the enumeration lists at the end of the technical specification as well. We also provide a partial reference attribute, and this is a Boolean value, so true or false value, and it will be true if we have used a network reference location, and it will be false if we've used a full network reference. So it's just make it slightly easier to distinguish between the two. We also optionally provide a maintenance authority attribute, and this is populated only if the section of highway is maintained at public expense. And this is the authority that's actually responsible for the maintenance. And this may be identical to the highway authority, but doesn't have to be. And there are two examples I can give you with that. So for example, if the maintenance authority were to be Highways England, then the highway authority would also be Highways England. They're a bit of a special case in this case. But for example, if the highway authority was City of London, the maintenance authority could, for example, be Transport for London. So maintenance authority look after the highway, highways authority just happen to be the area the highway falls within. That concludes maintenance, and I'm going to hand back to Diana now for the reinstatement.
Thank you, Phil. So on the reinstatement feature, another type of authoritative data we have in our highways product. The reinstatement basically defines the standard to which the path must be restored to following opening due to works in the highway as defined in the national policies, such as the New Roads and Street Works Act specification for the reinstatement of openings in highways, that is in England and Wales. or for example, in Scotland, you can have the New Roads and Street Works Act and 1991 specification for the reinstatement of openings in roads. In terms of the reinstatement feature, that will reference back to the path network through a network reference, as Phil just showed earlier, and we reference back to a street feature. Features which are a partial reference will provide a network reference location. Again, for more information, please refer back to the earlier slides, or if you want, chapter number 3 in the technical spec document. In terms of attribution for the reinstatement feature, I mentioned the partial reference. You also have the reinstatement type attribution, which gives you basically the reinstatement as defined in the policy document I just mentioned, and it has a reinstatement type value code list, which can be found at page 55 in the technical spec. The reinstatement type value code list has values such as carriageway type 0 or carriageway type 1. This basically gives you information on the capacity, limiting capacity of the carriageway that can be between 30 and 125 million standard axles, and so on. This is basically as defined in the codes, in the relevant codes of practice. With that in mind, this is basically summarizing the actual short and sweet attributes on the reinstatement feature. Up next, we have the next feature coming from authoritative data, and that is special designation, for which I would like Phil to explain a bit more. So over to you, Phil.
Yes, so the special designations advise of additional information relating to the carrying out of works on a highway. And this really can be more or less any type of information about what is underneath, above, next to, close to, or around a highway. But it can also be information about, for example, an event taking place, or other information that is relevant or has special significance to this section of highway. One note of caution with the special designations at the moment is that the data quality is very dependent on the population and frequency of reporting by local authorities, or local highway authorities rather. And however, there is work ongoing, and this will improve over time. So where it might seem that certain special designation values aren't fully populated or very geographically centered, that's probably because work hasn't been going on yet to actually improve this. The reference again is to a street feature via a network reference or network reference location. And in terms of the values, we have two mandatory values. The first one being, again, the partial reference, which is true or false, depending on whether it is a partial network reference or a full network reference. And the designation. If you want to know more about designation, you can see the big box here, the big blue box here with loads of values in it. The best thing to do is go to page 55 in the specification document, and you will find an actual explained table of what each of these values mean. But to give you an example, these could be local considerations. So is there something in the locality we need to be aware of? Or it could, for example, be special event or protected streets. There's a whole range of designations that are ongoing and that could fall within this. We also provide 3 optional attributes, and the first one is called contact authority. This is again a responsible authority type value, and effectively gives the authority to contact for further information about this designation. Generally speaking, unless you're absolutely sure you know 100% what the designation means, our recommendation would be to contact that authority for further information and clarification, more crucially. We also provide a description, and description is a free text that is taken directly from the NSG, and it provides additional information about the designation. So it could, for example, provide event information, or it could give an outline of what a local consideration might be. Finally, we provide a time interval, and this is a time interval or temporal property type, which gives the time and the dates that the designation applies to. So this could be a time interval or specific times or dates. That concludes special designations. I'm going to hand back to Diana now for highways dedication and a closure. Just a quick reminder, if you want to ask us any further questions, if you bring them up now, then we can probably answer them by the end of the webinar. So if you have any, just pop them around now.
Thank you, Phil. And thanks for the shout out for the questions. So please do ask in the box in the webinar window. The final attribute we will be talking about today is the highway dedication, and then we will have a short wrap up. The highway dedication is the final attribute, and also it's a type of information we have from local authorities. The highway dedication provides an indication of the type of the highway user who has access to a particular section of the highway. I would note here that the highway dedication value is only an inference of where a public right-of-way exists, and therefore not the definitive record of public rights-of-way. That is a definitive map held by the relevant authority. A highway dedication feature will also reference back to the path network through network reference, and will reference either a path link or a street feature, or in some cases both. Depends on the way we source the data. So when we reference the street, this means that this is what happens in the MSG, and that way you can retrieve a view of the highway dedication for the entire street rather than for each elementary street unit section, for example. We also reference the path link for the same reason. So the reason we made it have its own geometry, for example, in the elementary street unit geometry, is because we wanted to keep it the same as the source. And there was a risk that by making an attribute of the path link, we might end up moving the start and ends of these dedications. Likewise, if the ESU does not match a path link, for example, so OS geometry, then the dedication would not have made it out to the product. So that's why we sort of made it to reference either the path link or the street, or both in some cases. In terms of attribution, I would like to discuss here. We have the dedication attribute, which gives you the type of highway dedication that applies to the section of the street. We have, again here, a code list, which you can see on the screen in the blue box, the dedication and value code list. This can also be found in the technical spec document, and it has values such as byway open to all traffic, and that is a byway which restricts for all vehicles, or it can be a pedestrian way or footpath, so a way for pedestrians only, also known as pedestrian way or walkway. It excludes the footway, and so on. You can see the full list in the technical spec document. Also, we have, if you look at the orange box back here, we have the time interval, which gives you the time period to which the dedication applies to. We also have the public right-of-way attribute. However, again, this is only an indication, so it's not a legal term, and it gives you the indication if the dedication is subject to a public right-of-way. You have the national cycle route attribute then, which gives you basically information if the dedication is subject to formal cycle classification. It's a Boolean type of attribute, true or false. We have the obstruction attribute, which gives you an indication if the dedication contains a physical obstruction to vehicles. The planning order, which gives you an indication if a pedestrian planning order applies to the dedication. And then finally, the geometry attribute, which gives you basically the center line of the dedication. With that in mind, we finished the attribution for the highway dedication, and now we will move on to the sort of final explanation and the relational model of the path network. And on the screen now, you can see the diagram, the relational model. The attribute at the arrowhead is basically the primary key, whereas the attribute at the base of the arrow is the foreign key. So, for example, just to explain a bit better what this means, a path link is topologically referenced by the path node. So you can see here the relationship. The foreign keys here are the start node and end node. So the path link feature attributes, and the primary keys are the IDs of the path node. So basically, this is how they reference back to each other, how the path link are referenced back topologically to the path node, so you know which is start node and end node. And this is how they relate to each other. Again, you can see the relationships built here. Highway dedication, the last feature we talked about, references back to the street or to the path link. So this is how they all relate to each other. And you can build your network together using, for example, this. And then you have the functional side, which can give you the reference back to the OS MasterMap sites layer. So with that in mind, I would like to conclude as well with this slide. The highways product family we discussed over the last few webinars. So we had a session in December and then the January, which we covered all 3 products. You can see on the screen now the type of feature components. You can see as well loaded for each product. What I would like to emphasize is that you can also choose what you need from the data, what you want to load from the highways portfolio. So for example, if you're just interested in the road network, you can have the roads product. If you're interested in routing and asset management, the second product, RAMI, which is used with the roads product, might be for you. Or if you're just looking for paths data, then the paths product is ideal for you. Of course, having all 3 together will give you a full view and authoritative highway network for Great Britain. The key message about highways product family is that you have a framework for your authoritative data, while you have the geometry, the network, the road and path network together synced. You also have persistent toys, which will give features that have come from the previously OS IDN layer. So the identifier will be persistent. You will not lose any information. We have the same toys across the features and correspond to the same features in ITN. You have also additionally tunnels and bridges information, road widths and weight restriction, junction information, tracks. Also, you have the road names now held at the road link, or the path names held at the path link. So it's a bit more, hopefully, more easy to use and allows you for better querying of the data. We also have 3D height information in our highways product, the European routes 10T network, the non-geographic supply, which allows you as well for better data management, a download single zip, and of course a frequent delivery. So the highways product is delivered monthly each month. You can have the highways, all 3 products are delivered monthly. I hope we covered the deep dive explanation for all of the products. And if you have any questions either now or at a later stage, please do shout either in the webinar window, or if anything comes to mind later on, give us an email and we'll be happy to respond and be in touch with you and support you in any needs you might have from our data. So with this in mind, I would like to thank you for your patience throughout the webinars, and please let us know if we can help with anything. So thank you very much.